designed for various verticals, but yeah, it's a bit of a, it can be used in various verticals, but yeah, there's an antenna-only solution, but also a CPE available one. But before going into the more difficult CPE one, let's start with the easier antenna-only one. So what is the SWIRL antenna-only solution first off? So on the antenna-only version, we have an 8x8. The flagship one would be an 8x8 cellular one with 4 Wi-Fi and GNSS solution. So this is but it will be available in either an 8x8 or a 4x4. But the flagship one will be our 8x8 one with 4 cellular, 4 Wi-Fi and 1 GNSS antenna. The SWIRL was mainly developed for either the maritime industry or the transportation or mobility sector. So it has been designed with all these rough environments in mind, such as high wind resistance, water ingress, dust ingress, and just overall impact related. So yeah, this antenna has been designed to be as rugged and durable as possible, and to also be as future-proof as possible. So this antenna actually operates from 600 all the way to 6,000 with the cellular antennas, with the Wi-Fi antennas being Wi-Fi 7 compatible. So you can see the Wi-Fi antennas are covering the 2.4 band, 2.4 gigahertz band, and also the 5 to 7.2 gig. We will be having the SWIRL antenna in 2 available configurations. So it is SWIRL 4, which is 4 5G ports, 4 Wi-Fi ports, and 1 GNSS port. And then we'll have the SWIRL 8, which has 8 cellular ports, 4 dual-band Wi-Fi ports, and 1 GNSS port. So yeah, we're going to try and keep it simple with these, just 2 configurations to start with, and then we'll see how it goes. But yeah, these cellular antennas aren't just normal cellular antennas. There's a bit of a benefit with these cellular antennas, is that these 8 cellular antennas in the flagship, they all cross-polarized. So we have 4 vertical elements. As you can see here, there's a bit of a snapshot of how the antenna looks like when it's opened. So those gray, almost oval-shaped elements there are our vertical elements. So that's our high-gain vertical elements operating from 600 to 6,000 with a peak gain of 6 dBi. And here at the top here, you see it's almost like a bit of a saucer, but it's actually there's 4 horizontal elements there at the top. And these horizontal elements are also operating from 600 to 6,000 with a peak gain of 4 dBi. And the vertical with horizontal gives a cross-polarization. And I'll touch on that a little bit later, but that's a massive benefit that the customer would actually be seeing. On that, we have the Wi-Fi elements that are all vertical. So you can see the orange elements here. That's all we have 4 equally spaced Wi-Fi ones going around the antenna. And then we'll also have a dual band GNSS antenna. This isn't a single band now, it's a dual band GNSS antenna operating in the L1 and the L5 bands. Now this will provide much better GPS and satellite precision coverage, and also just much more durable especially for maritime. If you're out in a deep blue sea, or let's say you're doing long distance coverage in a vehicle or a bus, that you have that dual band GPS coverage, and you don't be able to lose connection or a lock on your satellites. So that's just a bit of a short and long of it. But on the measured results, so how do these antennas actually perform? I mean, we have them in there, but are they actually fantastic across that whole band that they operate in? And the question is yes. We've designed these antennas. We've spent months trying to polish this apple, and we found, as you can see here, we have a constant peak. So these are our vertical elements, as I saw those as almost oval-shaped ones. You see they're operating fantastically across the band from 600, where they have a peak of 4 dBi there, going up to 6 at 23, 2400 or 2200, and then going a bit down. But yeah, I mean, gain is constant, and it's constant coverage from 600 to 6,000. So that will help with near and far communication from the shore or from inland or close in the city, wherever this antenna is going to be used. So yeah, this is fantastic. And on the pattern side, these are our radiation patterns on the antenna and how they go from across the entire frequency band. You can see at the top, this is actually our elevation, so it's our side view. if you look at the antenna from the side, how is it radiating? You see everything is on the horizon where it's radiating but upwards, but that's where we expect the antenna, if this is on a vehicle, where it's going to be radiating but upwards because that's where the base stations are, and especially on the maritime, when you're at sea level, the base stations might be a bit raised up. So this is where we design in such a way that the patterns are controlled and radiating in the optimal direction where we expect the best signal to be coming from. And you can see at the bottom, we have our azimuth pattern. So it's actually a top view looking from the top down. You can see you want a perfectly omni antenna. So no matter where you're rotating, you can see that the antenna is going to be providing reception and coverage no matter what side it's facing towards. And this is actually from a single element. So this is not a combined all elements now. This is the pattern. This is actually from a single element. So we have 4 other verticals that are also equally spaced. So if you combine all 4, you will have a perfectly omni antenna to provide that omnidirectional coverage. And just to also note that these measurements here, they're our actual measured results. They're not simulated results. We do simulations, but then we design our things, we manufacture it, and we measure it actually, and then we can provide these actual measured results that customers can expect, and not simulated results that the customer might expect. Just that because we take a lot of pride in designing our antennas. So this is on our vertical elements. So all the antennas, the SWIRL 4 and SWIRL 8 will have vertical and horizontal. And then on the horizontal side, the horizontal elements are all, as mentioned, also operating from 600 to 6000. And you can see it's still a highly well-performing antenna from 600 to 6000, with gain in the low band actually being very well for such a small compact size. We got 2 dBi there, and then going to 4 dBi at 2.3, 2.2, and yeah, just complementing the vertical with the horizontal. It will make a massive difference in the customer's overall experience. But yeah, I will mention that now. And what would that benefit actually be? But yeah, looking at the patterns, and again, you can see the patterns here, they were designed in such a way. Again, you have the perfect omni patterns on the side, the elevation. You can see it's radiating on the sides. That's where you actually want them to be. And that's where the majority of the signal will be coming from, that from the base station and from the reflections as well. And then at the top here, again, from the azimuth, you can see it's perfectly omni. And as mentioned, this is actually just single element patterns. If we combine these with all 4 horizontals, you will again get they will complement each other, and the one will fill in the other one's gaps and provide a perfectly omni radiation pattern. So no matter where the boat or the vessel or the bus is turning towards, it will have a constant connection. Yeah, and that's just the big benefits on, and we take a lot of pride in designing our omni antenna. Well, our antennas in standard, but radiation patterns are key for us. I mean, we might not have the highest gains, we might not have, because customers always think peak gain is fantastic. No, we need the highest gain antenna. But yeah, you might have a very nice high gain antenna, but if there's dead spots everywhere, you're going to have a very bit of a fluctuating signal, which is not ideal. And with this, we design our antennas to achieve the best possible gain, but without compromising on the radiation patterns. That's our key focus here at Poynting, to give customers a bit, peace of mind. Now, complementing the cellular antennas is we do have Wi-Fi antennas as well. So if customers want to access the Wi-Fi on the router through the antenna, they can do that. You can see the dual band Wi-Fi antennas. They're operating from 2.4 gig and also from 5 to 7.2. So they're completely Wi-Fi 7 compatible. Yeah, they can be used to access the whatever router they want, customers want, with the Wi-Fi from the antenna. And pattern-wise, this is also fantastic patterns. And you can see it's great. Radiation patterns are perfectly designed to be on the horizon and where the majority of the signal will be coming from. So you can see, again, this is just the radiation pattern of one element. But if you combine all 4 of the Wi-Fi elements, you will have a perfectly omni coverage on that. But I've been mentioning the whole time that with the SWIRL, the antennas are cross-polarized. So you have vertical and horizontal, everything's cross-polarized. But what does that mean? What benefit does this actually have for customers? What would they see? How would this affect them? Now, we had a bit of a mathematical model where we actually try and illustrate to our customers, now our customers, what is the effect or the benefits of cross-polarization, especially with this type of antenna. So as the SWIRL makes use of vertical and horizontally polarized antennas, uh, it improves the overall efficiency of a system. So the efficiency, so what is antenna efficiency? So for those of you who don't know, antenna efficiency measures how effectively an antenna converts the power it receives into radio waves. And how does one actually measure efficiency? It's measured in percentage-wise normally. So for example, if an antenna is 80% efficient, that means 80% of the power received by the antenna is radiated as a signal, while 20% is lost. Now, it's really difficult to have a perfectly 100% efficient antenna. There's always losses, real life, like cable losses, material, PCB losses, lost tangents and everything. So it's difficult to get 100%, but you can get close to it. Now, you can see it on the right-hand side. We did a bit of a mathematical model to illustrate what is the efficiency that you would see if you convert or connect two vertical antennas to a router as opposed to a vertical and a horizontal antenna. You can see a normal vertical and vertical will just be giving you a 50% efficiency from what you can expect. From your router's giving it 100% and it can only radiate 50%. But if you're now connecting it, let's say, for instance, to our SWIRL, which is a vertical and a horizontal, it's going to give you 80+% efficiency. So that's a 30% increase, 40% at or closest to the antenna. I mean, this is at separation, how far away from the antenna you will be getting. So this is from 0 meters to almost to 3.5 kilometers. And you can see this was just a mathematical model in free space. And just to give you an idea of customers, like, we constantly mention our antennas are cross-polarized and this is fantastic. And yes, it is fantastic, but it's so difficult to explain to customers what the benefits is that they will be seeing. So yeah, I hope that gives a bit of a better understanding of how efficient, how the cross-polarization affects the efficiency of the overall the system, and why it's so crucial to actually do cross-polarization, especially with high data requirements. If there's a lot of, then you have get the best out of your router or your modem. But size-wise, no, it's actually not that big. A SWIRL antenna, it looks big on the screen, but in perspective-wise, how does it compare to our existing product? So it's 382 millimeters in diameter, as opposed to, let's say, for instance, our MIMO 4, which is 162. So it's just about double that in diameter. But height-wise, how big is it? It's 127 millimeters in height. So that's actually, yes, double that of our MIMO 4, but it's actually lower in height than our MIMO 3 antenna. And our MIMO 3 is also a mobility antenna, and it's been used worldwide. And it's actually smaller in height than our MIMO 3. You can see it's a fantastic looking antenna, size-wise. And it's actually very low profile for the overall antennas, the amount of antennas that you're getting inside. But environmentally wise, how have we designed it? So yes, we have it has been designed to be IP69K resistant. So that means wind and water resistant, especially for so IP69K is the highest possible rating you can achieve for ingress protection, and that means it can withstand high pressure washes at different angles. So if you're putting this on a vehicle and you have, or on a bus, and there's high pressure washers to clean it, there will be no water ingress on the antenna side, and everything will be safe inside. It is also rust and corrosion resistant, so it was designed for saltwater spray protected, and also it has a UV stabilization in the radome. So it will keep it that nice brilliant white color as the time passes, when it won't turn yellow and brittle with time as the UV from the sun damages it, or radiates onto it. I mean, it does have UV stabilization in its to keep it that pristine, pointing white, high quality look and feel. It's also IK08 rated. And so on the mounting options, what mounting options will be available? So antenna only solution will have the following mounting options: a bit of a adhesive surface and also a magnetic mount, but more on that. So on the magnetic mount, so this is an optional accessory, but there will be there's spacing available beneath it, so it can have a optional magnets available that you can just have it as a temporary solution, stick it onto a surface. You also have a full-on surface mount, so you will have a thick adhesive tape at the bottom, and you can just stick that onto a surface and it will be quite secure. It's almost like a 3M tape, but it is a 3M tape. So yeah, as you've seen with our pucks, it's actually, once you stick it down, it does stick. It's so it can be surface mounted with the, you can see there's a bit of an opening there, so it's actually for the cables to run through and run out of it, just to help with the cabling of from the antenna side. And you can see also it's a bit of a surface mount, another surface mount. It is with mounting holes here at the bottom. And now these holes are spaced 233 by 141.5 millimeters apart. You might be wondering, that's a very awkward dimensions, but once I get into the CPE solution, you'll see why we chose those dimensions. Yeah, so just to wrap up the antenna-only solution, what are the key selling points on this? So it's Poynting's first 8x8 MIMO 5G mobility antenna for improved equipment and performance and throughput, especially with the cross-polarization. Provides ultra-wideband cellular antennas that operate from 617 all the way to 6000. It has cross-polarized antennas. So the cellular antennas are cross-polarized, and I mentioned the benefits of why that is so crucial and so beneficial for the customer. It has a peak gain of 6 dBi across the band for optimal coverage, and it has exceptional performance across the whole band. So the radiation patterns are perfectly designed across the whole band and not just in specific bands, but it's designed across the entire band. And yeah, it's multiple antennas in one, with up to 13 antennas in one antenna solution. So 8 cellular, 4 Wi-Fi, and 1 GNSS, one dual band GNSS antenna. And it's just a low profile, compact design. Overall, just a fantastic solution. But there is a bit of a party trick behind the SWIRL. Now, the SWIRL can be turned from an antenna-only solution into a complete CPE solution. Now, this was again designed completely for the maritime and transportation markets. So the various various maritime markets, various vessels, and also which can be used in. We have these two main ones, but it can be used in other industries. But yeah, we thought these are the main things we designed it for, because these are very harsh, very rugged environments. So how can you actually transform the antenna into a CPE solution? I mean, how do you do that? What's the party trick here, Ernst? So you take the antenna, you add a separate base, and then you can have an all-in-one CPE solution. And this base is it's not a big party trick, but it's a party trick. That transforms the whole thing into a complete CPE solution that's IP rated, and yeah, you know that you can install your routers right there. It's secure, it's safe, and you can just have the Ethernet cable coming out with minimal cable losses. So how big does this base make the overall and size-wise now? So it still has the same diameter, 382 in diameter, but it now transforms the height from 127 to 224. So it's around about a 100 millimeter increase in height, but I mean that's still really low profile. And how does it compare to our Ripple? I mean, diameter-wise, it's a bit smaller than a Ripple, but it's definitely less, well, much lower in height than our Ripple. I mean, the Wideband is just there for for interest's sake. But yeah, as mentioned, when we released the Ripple, then everyone wanted something smaller. So now we thought, yeah, it's something smaller, that it was perfect for the maritime industry, for those smaller vessels that customers might want, but also for other sectors. So environmentally wise, by adding the base, how does this affect the IP rating or the environmental conditions of the SWIRL? So it actually doesn't affect it at all, because we designed everything with everything in mind, that we want to keep the routers safe, especially for a maritime industry. We want to have it as secure as possible. So we will also have an IP69K rating with the base now on. And again, this was a rust and corrosion resistant, so designed with the saltwater spray protected, and also a high quality design materials used. The one thing I'm not mentioning is that the base, the entire base that comes beneath the antenna, is actually a solid casted aluminium base, and that helps with heat dissipation, especially with these 5G routers becoming so high performing and so it's so much heat that has to be dissipated. We thought, yes, we can do plastic, but this is not what customers want. They want something that is high quality. So we decided, no, we're going to design this base to be a solid cast aluminium base that we can give the customers the high quality that they want and deserve. And it's also UV, as mentioned, UV stable protection in there. But yeah, so where does it actually fit in here with our current maritime? I mean, as mentioned, it can be used for other industries as well. But where does the SWIRL fit in here with the other ones? So you have the smaller vessels, the small to medium, medium to large, and then the large, very large vessels here, where the wave and ripple are being used. So we're aiming the SWIRL for around about this small to medium markets. And I mean, this can be used for others as well, but this was just the sight we had, or the vision that we had with the SWIRL. But I mean, it can be used for bigger vessels or smaller vessels, depending on the capacity, the data's constraints, or the requirements that customers want, or yeah, their requirements overall.
Yeah, I think we can if I may add, basically this first one thing that I need to say, we call it a CPE solution, but there's absolutely no electronics inside of this antenna. Okay, so we're sticking to what we know. So we're making antennas and that's it. Then it has a router bay where, well, the enclosure, the base that Ernst has been showed you already, where you actually put your CPE, your router inside. It's just a CP. That's why we call it the CPE solution. It allows you to put your router, your CPE inside of the antenna. So I just wanted to make that remark. Still a passive antenna. Well, most the LTE antennas are passive. That's what I mean. So I just wanted to make that note. And then on this image, it's an image that we really like, because if you read it left to right, the antennas are increasing in size, and you know, because you've heard a number of our webinars, that traditionally translates to higher performing antennas, especially on the lower frequencies, and especially if you're taking into account omnidirectional antennas only. So this increase in performance, you could almost think about it like from left to right, you're also catering for vessels that have higher data needs. So if you have a vessel that's very small, or the vessel may be small, but there's not a lot of people using the internet or using the connection, and it doesn't move too far away from shore, the smaller antennas can be a fit. And as you move further to the right, you would be seeing and looking at antennas that are capable of delivering higher throughputs and further away from shore, and do that while there's less signal available, right? So we will hopefully in 1-2 weeks release from this diagram a couple of variations where we show you, especially for the maritime world, this evolution from left to right, with data needs increasing, distance from shore increasing, and signal availability decreasing. So here, this slide pinpoints the antennas to the vessel size, but that's also connected to the vessel size. A lot of times there's also the data need requirement and how far away from shore that vessel will be traveling.
Definitely. No, thank you, Hugo, for adding that. I think that's very valuable for the customers to know. And yeah, I think this is a CPE solution, meaning that it's like our ripple and our wave under. There is space for a router. We don't supply the routers, but you can add that in there, and I'll add onto that a bit later. Mention again, where does the SWIRL CPE solution fit in? So we had our, as mentioned, it's for the smaller vessels, maybe for the less data requirements. Then we had the ripple for the much more bigger luxury yachts, and then we have the wave answer for the very large vessels that have maybe high data requirements or long distance communication requirements. So yeah, that's just where the SWIRL comes in. Just give a bit of an overview, but as Hugo mentioned, there's various factors to it. but we will be releasing something in the coming future to help clarify and where does it fit in and what will be best for your needs. So again, on the getting to the base, as mentioned, this is the base customers will be buying is a fully cast aluminium base. So this is to completely help with the heat dissipation inside where the routers are installed. And you can see the mounting of the base. It has again that awkward mounting dimensions of 233 by 141.5. Now again, you mentioned where does this come into? Now we're designing this in such a way that that dimension is the standard marine mounting dimensions for various mounts, radar mounts, or mast mounts, tower mounting pedestals. I mean, for instance, so this will make the SWIRL compatible with the industry standard brackets for the mast and radar towers. I mean, there you have the scan-shot brackets, you have C-view brackets. So we design in such a way that customers can buy the SWIRL and just install it on there. And it's a bit of a plug-and-play solution. They don't need to buy custom brackets for it, or we need to make a new bracket for it. I mean, there is already an industry standard, and we design it in such a way that it fits right onto those brackets. And I mean, customers are already used to that form factor, so we decided, no, this is I think the easiest way for customers. And as mentioned, the antenna only version, it has the exact same mounting options at the bottom. So you can either install just the CPE solution there, or you can install just the antenna solution on these mounting options, just to make everyone's lives a bit easier and much more versatile. But yeah, getting to the router space, how much router space is actually available inside the SWIRL? What can you actually fit inside there? Just a 4G router, or what can you do? So no, it actually has a lot of space in there, and it has the one dimension is a 290 by 290. It's a 293 by 248 by 50 in height, and in the other dimension is 230 by 185 and 193 by 50 in height. So we have so the following routers will be able to fit inside the SWIRL. It's the PaperLink Max PR2 Pro or the MBX Mini, the Cellular Stratus 5G, the Cradlepoint IBR 1900, and the RUTX Teltonika RUTX 50s. Actually, two of them can fit in here. But what's nice is you can see there's a plate here at the bottom, and it looks like a bit of there's holes there, pre-drilled holes that we'll be including as standard. And those holes aren't there just for heat sinking. Those holes are actually pre-drilled holes for routers that we have designed this for. So pre-drilled holes to help with the ease of installation of routers inside the SWIRL base. So you can see here's an example of the Cellular Stratus 5G, already pre-drilled holes. Customers can just secure it there, mount it, and then they can connect the antennas and they're good to go. And there's the IBR 900, the PepLink MBX, because unfortunately there's no flanges on it, so you can't secure it. So we have our brackets that can be used to install it. The PepLink Max PR2 Pro that has side flanges that will help with installations. So it has pre-drilled holes, and also for instance, the Teltonikas, you can fit two Teltonika RUTX 50s or RUTC 50s in there without any hassle. So that's I think that just gives a customer that peace of mind, because we're a router agnostic company. We try to keep it as easy and comfortable for customers to install their router. But how do you access the router from outside? So we have included two cable routing options to help with the routing of so the one is a bit of a cable pass-through gland, where you open this, you pass through the cables, and then you compress it. And the rubbers that we're going to be using are high quality rubbers that have the shore hardness that is, yeah, we tested various compatibilities, but then we found the perfect one that has sufficient, let's say, formability, but it's still hard enough to withstand the harsh, let's say, for instance, sea conditions out there. So that is on the one option here. The other option is a Ethernet gland. It's gonna be a stopper, but then it's an M25 hole that can be opened up, and an Ethernet gland or Ethernet port can be installed there or secured there to just have easy access to the routers. And you can see there's a bit of an orbit here at the bottom, or a plate, and this is to help with cable routing So if the Ethernet comes out, take it through here, secure the cables. So the cables, that there's no pull force on the cables from below. So that there's a cable strain relief. That's the cable strain relief plate to help with that there's no damage to the cables and that not all the force is on the connector side. But yeah, the reason why we went with the SWIRL is because the form factor is what customers are already used to. On almost every second vessel, you see these radar domes on them, and customers are already used to this. I mean, we're not comparing or competing with this. This is just to give an idea that these radar and GPS domes and radar domes, that this is what customers are used to, and we're designing in such a way that this is the first cellular maritime one that's actually available, and they can just maybe take this off and install ours if they want. But yeah, it's the exact same roundabout form factor that customers are used to, and it'll be easy for them to install one. Yeah, it won't be an eyesore for them. So what are the key selling points from the SWIRL CPE solution? Is yeah, I mean, taking the antenna one as is, just putting the base on, gives customers that 8x8 MIMO 5G CPE solution. But I mean, it can also be a 4x4 MIMO 5G CPE solution because we have the SWIRL 4 and the SWIRL 8. And it is cross-polarized. The one thing I did forget to mention was yes, the antenna is cross-polarized, but there's the SWIRL 4 and the SWIRL 8. If you take the SWIRL 8, the SWIRL 4, there's only 4 cellular antennas, but they're still cross-polarized, so 2 vertical and 2 horizontal, because we found that it's better to have 2 vertical and 2 horizontal instead of 4 vertical. And so yeah, just to make that clear to you. Then that base on the CPE solutions, it's a full-on cast aluminium base. We didn't spare any expenses there. We thought, let's give the customers what they want. There's ample space for any 5G routers in there, and it's actually it's an affordable and reliable maritime connectivity solution. And yeah, I mean, there is the standard marine mounting options there, just to, you don't have to buy custom brackets. You can use existing marine standard brackets to mount this onto there, and also the cable accessories or accessing of the routers with a cable. That will just also be peace of mind. We had a bit of a unit that we made. I'll actually show it here, or before I show it now. We had a unit made, and we sent it out with our CEO to where he was on a trip to Croatia, and we installed it there for some field testing, and it turned out, and it looked fantastic. It's yeah, you can see there, it looks fantastic. It's actually much smaller in person or in on the pictures than you actually might think it is. And yeah, we found that we didn't even, this was a prototype that we made, and even with the wind conditions and everything, there was still no water ingress. Everything was perfectly fine. And yeah, it turned out fantastically well. I just want to actually turn my screen off and just share you. We have this prototype here with me. Okay. So you can see here's what an actual SWIRL will look like. You can see it's actually not that big. I'm just small, but it's actually a very compact size overall. And yeah, having space inside here, it's actually, yeah, it's a very compact solution and easy to install. I mean, 1-person installation, and just quick and easy to do from a CPE solution side. But yeah, that's all from my side. Thank you.